Hi, I'm Aziz from Siemens Digital Industry Software, and this is the Summer 2023 release of NX. We're always working on new features and enhancements for NX as part of our continuous release program. The latest release includes some amazing updates that will help you and your team design better and faster. There's new functionality to discover across every major workflow, from EDA to manufacturing. We're going to introduce some of our highlights with a focus on how NX can help you integrate environmental sustainability into your design and engineering processes. Here's what we'll cover: our approach to sustainability with Siemens Xcelerator platform, our case study and the product design process behind it, new tools to validate moulded part designs for manufacture, NX's new performance predictor for real-time design simulation directly in the CAD modelling workspace, how to create high-quality visuals for validation and user testing with Appearance Manager, and throughout, we'll showcase how these features and the new Sustainability Impact Analysis tool can help you design more sustainably. Let's get started. Every day, NX and Siemens Xcelerator platform help thousands of users design and manufacture more efficiently. That means everything from cargo ships to laptops, consuming fewer natural resources and using less energy. We know how much sustainability means to your organisation and how regulatory pressure and ESG reporting can impact your operations. And we also know that you can identify and reduce 80% of your product's environmental impact during the design phase alone. For us, sustainability is a way of thinking. It's about taking the rich foundation of data that's already at your fingertips and presenting it in the right context at the right time. By leveraging the world's most comprehensive digital twin, Siemens Xcelerator enables you to understand the environmental impact of your products throughout the design process. With transparent, accessible, and reliable data available to everyone, designers and engineers are empowered to make informed decisions with every iteration. This left shifting equips your teams to maximise circularity for the full product lifecycle. That's how you change mindsets and embed sustainable thinking into everything you do. So let's see how it works. This is a design studio for an established designer and manufacturer of commercial espresso machines. They have a successful range of products for cafes and restaurants, and now they want to break into the consumer market. The company has also identified sustainability as a possible competitive advantage and has introduced related targets across all their product lines. That means designing a new machine that's better suited to use at home. It needs to be small, easy to use, reasonably priced, and energy efficient. The executives have also given their engineers and designers some additional requirements. The new model must reuse as many parts as possible from the existing range to keep costs and supply chain complexity low. It must also meet the company's new sustainability targets. The requirements for the new model are all represented in Teamcenter as engineering change requests for the design team to review. All the internal components for reuse are also present with full material, supplier, and cost data associated. The designers will start by creating a modified version of the existing commercial product with one dispenser instead of two, and this gives us the internal reference around which to design the external package. Using the existing parts in a new assembly is a seamless process thanks to the close integration between NX and Teamcenter. And with material properties already assigned, every part is ready for simulation and analysis within NX and SimCenter. However, market research showed that the functional industrial style of the commercial machine didn't appeal to their target consumer demographics. NX's advanced modelling tools allow the designers to soften the appearance with complex, organic geometry, resulting in a smoothly curving exterior. The stylish new exterior shell looks great, but now we need to think about how to manufacture it. We joined the process after the team has decided it will be moulded from ABS plastic in 4 parts. The next step in NX's new moulded part designer is to add the ribs, bosses, and other standard plastic features with real-time validation. These moulded features make it extremely quick and easy to position the necessary elements in the correct places. Each parametric feature can be modified across a wide range of variables for different use cases. And the tool can also help verify the manufacturability of each feature in real time before you add it to the model. Now we've added in all the necessary moulded plastic features, including bosses, snap fits, ribs, grooves, and drafts. Next, we can run an additional overall validation of the part and its features. We can see some warnings about certain features that we may need to investigate further to avoid defects, but overall, the part looks ready for manufacturing. Validating design for manufacturability early in the product development process means fewer design iterations before going to market, saving the company significant time and money. Performing this validation with a digital twin also contributes to the sustainability goals by reducing the amount of physical testing required and the material and energy wastage involved. And with moulding processes optimised with NX Manufacture tools and NX Mold Wizard, the company will waste fewer resources due to manufacturing defects during production too. Next, let's take a look at one of the internal parts. While the team wants to reuse as many parts as possible from the commercial products, they must balance this with reducing costs to keep the retail price affordable for consumers. This swinging mechanism compresses or tamps the loose ground coffee into a solid puck before hot water is pumped through to create espresso. In the existing commercial machines, this part is made of aluminium, which is quite expensive to produce. So the team want to explore different material options whilst maintaining performance and durability. The designers can use NX's new performance predictor to simulate the part under load in real time, whilst exploring different design and material choices. This heat map shows the level of strain across different areas of the part, and we can see that the strain is highest right here on the existing part. If a weaker material is going to fail, it will do so at these points. We can even automate a whole batch of tests at the same time using Design Space Explorer, covering a range of different material and geometry variables. The report output shows us at a glance the optimum variables for the test criteria, which meet feasibility requirements, and which have failed the test. And we've done all this entirely within the NX CAD environment. We can see that steel is the most durable material tested, and that there are some other feasible alternatives too. Now, steel would be cheaper than aluminium, but remember, there are also sustainability requirements to meet. Both cost and sustainability improvements will multiply as the company ramps up from commercial to consumer production levels, so it's vital that they find the right balance. Which of these materials would be the most environmentally friendly choice? Using the new Sustainability Impact Analysis tool, we can see the environmental impacts of different material choices at a glance. The report shows you the estimates for the CO2 produced and water used to create the materials in a model. This data is available as granular as you need it, at the part or assembly level. Let's compare the amount of CO2 production involved with our material choices for the tamper. We have a range of results for the feasible material choices, and if we compare steel with the original aluminium, it also produces less CO2. Now the designer has verified their changes with initial design simulation, they've passed the data to an engineering team for full engineering simulation in SimCenter. In SimCenter, the part undergoes a wide range of rigorous testing for performance under pressure, mechanical strain, and high temperatures over thousands of use cycles. Now, fully verified for durability and sustainability, the team can commit their changes to Teamcenter, ready for production. Next, the team needs to make some final decisions about the coffee machine's outer shell before they report back to their stakeholders. They want to validate their choices for both sustainability and aesthetic appeal to their target market. We know that the shell will be moulded from ABS plastic, but the company can source that ABS from different suppliers. Would one of these material choices help improve the sustainability of their product? Let's return to the Sustainability Impact Analysis module. Our designers have assigned the different plastics to the relevant parts, and the report has some interesting results. Although the difference in CO2 production between the three is small, this option includes a much higher percentage of recycled materials. The designers know from Teamcenter that this material costs a little more, but they'll recommend it for use due to its superior environmental credentials. Now the base material is finalised, the designers are thinking about colours. Historically, the company has conducted focus groups with physical prototypes in its corporate headquarters. However, producing these prototypes is costly and time-consuming and uses extra energy and materials. This in-person testing also restricts the company to feedback from people living nearby. This time, they're going to use NX Render and Appearance Manager, components of a comprehensive digital twin, to get initial feedback on a number of colour variants without physical prototypes. This also gives them greater flexibility during testing, and they can present their focus groups with far more options than they could before. Appearance Manager creates photorealistic 3D renders of parts and assemblies with an extensive library of colours, finishes and coatings to choose from. And designers can generate these renders within NX itself, without needing to export data to another program. They all look great, but these three are the focus group's favourites. The team will now create physical prototypes of these three for final validation. The design process is finished, and the team can present the final prototypes to their stakeholders for approval. They've met all their initial design requirements and achieved a range of improvements using new NX features. They've improved the durability of internal components, reducing wastage and supply chain impacts. They've chosen environmentally friendly materials throughout, reducing CO2 emissions and increasing the amount of recycled material used. They've reduced the likelihood of manufacturing faults with thorough digital validation and simulation. And they've achieved all this with fewer physical samples and prototypes, avoiding the associated time, energy, and financial costs. That's all we have time to show you here, but there's lots more to discover in the summer 2023 release of NX. Follow the link in the description for further information about new features and enhancements. And if you want to learn more about the workflows we've covered here today, subscribe to the channel to be the first to know when we release upcoming deep dive videos going into more detail. Thanks for watching.